Now in the last lecture, we have learned different types of data structures. In this lecture, we will look at types of algorithms. Now in these lectures, there might be some terms that you may not understand and you might have difficulties with understanding the concept. Don't worry about that because everything that I mentioned here will be discussed in detail in upcoming lectures. Algorithms can be classified based on the problem they are trying to solve, such as sorting algorithms, searching algorithms, and so on. Or they can be classified based on the problem-solving approach. Please note that here we are just classifying together the algorithms that use a similar problem-solving approach. The purpose here is to highlight the various ways in which a problem can be attacked. Based on these criteria, algorithm types can be simple recursive algorithms, divide and conquer algorithms, dynamic programming algorithms, greedy algorithms, brute force algorithms, and randomized algorithms. Okay, let's see what these algorithms are about. The first type is simply recursive algorithms. Such algorithms work in the same way as iterative algorithms. The recursion acts as a loop. If you hear a recursion term for the first time, you can think of this an algorithm that calls itself recursively. I will explain it in detail in the recursive section. The sample algorithm for recursive algorithm can be like this. Here, as an input, we have an array A of n numbers, and the output is the sum of numbers in the array. Here, the algorithm first checks the number of elements. If the number of elements is 1, then it returns the first element. Otherwise, it recurses all elements except the last one and adds the last one at the end. This sample shows how recursive algorithm works. Here you see that inside sum function, we are calling the sum function itself with different parameters. This is how recursion works. The next type of algorithm is divide and conquer algorithms. This type of algorithm consists of two parts. First part is they divide the problem into smaller subproblems of same type and solve these subproblems recursively. And the second part is we combine the solutions to the subproblems into a solution to the original problem. Traditionally, an algorithm is called divide and conquer if it contains at least two recursive calls. Quicksort and merge sort algorithms can be examples for divide and conquer algorithms. Okay, here, then we continue with the dynamic programming algorithms. They work based on memoization, which means that these algorithms remember the past result and use them to find new result. These type of algorithms are generally used for optimization problems. The goal is to find the best solution among multiple solutions. Here again, I don't want to go in details because, as I mentioned before, these algorithms will be discussed in detail in upcoming sections. Okay, we'll continue with the next type of algorithm. The next type of algorithm is greedy algorithms. These algorithms are also for finding the best solution. They work well for optimization problems. A greedy algorithm works in phases. At each phase, we take the best we can without worrying about future consequences, and we hope that by choosing a local optimum solution at each step, we will end up at a global optimum solution. And the next type is brute force algorithm. It simply tries all possibilities until satisfactory solution is found. For instance, finding the best path between two locations. And the last type is randomized algorithms. These algorithms use a random number at least once during the computation to make a decision. You will see in the upcoming sections that the quicksort algorithm works based on random number to choose a pivot number and make a decision based on this. And with this, we have finished the last type of algorithm. Okay, that's all for this lecture, and hopefully you have an idea now on different types of algorithms. And this is the last video for this introductory section. From the next lecture, we will start with a new section in which we will learn everything about Big O notation. See you there.